In this video, we are going to compute the surface integral here of x squared z plus y squared z ds. Now, what is our surface? Hopefully you realize that z equals 4 plus x plus y because there are no squares. It's just going to be a plane, but this plane is not the whole plane, but it's just the part that is inside the cylinder. So the cylinder is cutting a piece of that plane, and the cylinder has equation x squared plus y squared equals 9. So I wanted to show you what that looks like. So in the graph here, let me just make this larger. So this is your circle, right? So this is that x squared plus y squared equals 9. And so you are inside the cylinder. And so your surface is this yellow, I guess you can, I'm not sure that this is an ellipse maybe, but like it has a form of an ellipse, right? So it's just going to be part of that plane that has to be bounded by that can or whatever, the cylinder. So you cannot get out of it. So it's kind of like a slanted circle, which is an ellipse, most likely. Okay, so anyway, this is what we're trying to do. We're trying to integrate over this yellow surface. Let's see how we do that. Okay, so let's switch to integrating from a surface integral to an actual double integral. So how do we do that? Well, we need to compute the differential ds, and the formula for that is square root 1 plus gx squared plus gy squared. So what is gx and gy? Well, these are the partial derivatives of whatever is the equation of the surface in the format z equals g of xy. So it's pretty simple to see that g with respect to x is just going to be 1, right? Because 4 goes to 0, y goes to 0. gy is going to be also 1. Okay, so then this is going to be simply 1 plus 1 squared is 1 plus, again, 1 squared is 1, which is square root of 3. So that's the relationship between ds and dA. So that's square root of 3. Okay, now we need to figure out what are we actually integrating. Well, we're integrating this x squared z plus y squared z. But remember that because you are on the surface, you are in that slanted whatever circle, ellipse, so you are staying there, and on that surface, z equals 4 plus x plus y. So you cannot use z in there. You have to, when you switch to double integral, substitute what it is. So let's see if we can figure it out. So I'm going to factor out z because it's in both terms. And z, instead of z, I will substitute 4 plus x plus y. And then, so this is my z. I factored it out. And then in parentheses, once you factor z out, you get x squared plus y squared. Okay? And then instead of ds, we put square root of 3 dA. That's quite a bit of stuff. So we're trying to integrate this over the projection on the xy plane. Now, obviously, the projection is going to be the circle of radius 3, right? So you can see that the surface, if you were to project it, basically take all the points and make the z coordinate equal 0, you're going to wind up with that circle of radius 3. So that's what you're integrating over. So integrating over the circle is 0 to 2 pi, because we are obviously switching to polar. Because every time it's a circle, switch to polar, 0 to 3. Now, we need to figure out what to do with all of this stuff. And that's going to be kind of challenging. So what do we know from polar coordinates? We know, if we go back to our formula sheet, one of them, that when we go to polar coordinates, well, this has a cylindrical, not polar, so I don't know if it's somewhere else. Let's look at it. What happens when you switch to, no, it's not, it's right there. Okay, so when you switch to polar, there's a couple of things that you need to remember. So first of all, add an extra r, meaning multiply by r. Also that x squared plus y squared equals r squared. But that's not going to be enough for us because we also have an x and a y. And x is r cosine theta and y is r sine theta. So all of that we are going to have to substitute. Okay, so let's do that. Let's substitute. So we are integrating from 0 to 2 pi and from 0 to 3. So 4 plus, instead of x, we're going to put r cosine theta. Instead of y, we're going to put r sine theta. Okay, instead of x squared plus y squared, we're going to put r squared. We also need to remember the extra r, and then we also have the square root of 3, and that's dr d theta. Look at that. That's a lot of stuff to put in. Okay, let's do that. So we're going to get 4 plus r cosine theta plus r sine theta, and then we multiply that whole thing by r cubed, right? And then square root of 3. So that's the ugly integral we are going to have to integrate. Okay, so let's see if we can integrate it. So let's go over here and let's integrate it. All right, so this is what we're going to do. So first of all, I'm going to pull the square root of 3 out. And unfortunately, at this point, I cannot just split it because I do have some theta in it, and it's not multiplied, it's added. So I will have to just distribute the r cubed to each term. So I will get 4r cubed plus r times r cubed is going to be r to the fourth. So you do understand that this is r to the power 3, right? Because the powers are added, and then you just distribute that r cubed to each term. So, and then we got another r to the fourth, this time sine theta. And we are integrating dr d theta. Okay, so first let's integrate this thing with respect to r. Okay, we can do that. So this is going to become r to the fourth, right? Because the 4 is going to cancel. Plus r to the fourth is going to be 1/5 r to the 5. Cosine theta will not change because cosine theta is a constant multiple. When you integrate with respect to r, we just keep it. And then we're going to get 1/5 r to the 5. And it's again, sine theta will stay sine theta because we are integrating with respect to r at this point. And d theta is still there. And then we got 0 to 3. Okay, so let's substitute. At this point, I'm not going to simplify. I'll just say 3 to the fourth plus 1/5, 3 to the 5, cosine theta, plus 1/5, 3 to the 5, sine theta. And d theta. Okay. So here's what's going to happen once we start integrating over theta. So 3 to the fourth is just a number, so it gets multiplied by theta. Here, 1/5, 3 to the 5 is just a number. Integral of cosine is sine. And integral of sine is negative cosine. So this is going to be cosine. But the plus right here will turn into minus. So never put the minus like in between over here. That will look like it's a subtraction, which it's not. It's multiplication. So always just switch the sign over here. If it was plus, just switch it to minus. If it was minus, switch it to plus. Okay, and then we have 0 to 2 pi. And at this point, we're going to notice something about the 2 pi when we substitute it. It actually will cancel out. So I'll show you that in a second. So let's substitute 2 pi first. So we got 3 to the fourth multiplied by 2 pi plus 1/5, 3 to the 5. Now sine of 2 pi is 0. So if you don't believe me, go to the calculator, make sure it's in radians, and you will see that sine of any multiple of pi, like 0 pi, 2 pi, 3 pi, is always 0. Now, cosine of 2 pi is 1, because it's the same thing as cosine of 0, which is just 1. Okay, so that's the top limit. Now let's substitute the bottom limit. So when we substitute the bottom limit, we're substituting theta equals 0, which is going to make the first term 0. The second term also 0 because sine of theta is 0. Sine of 0 is 0. And cosine of 0 is 1. Okay, so that's what we get. Now notice what's going to happen with that. That's why I did not want to even simplify this thing, because it's a lot of stuff is going to cancel. So this is going to become 3 to the fourth times 2 pi. And then, and I'll just pull out the square root of 3 out of this whole thing. Then this is going to obviously turn into 0. This is going to be negative 1/5 3 to the 5. And again, I square root of 3 I pulled out. These two terms are negative. And then there is, a 0, so they go away. And then this is negative, another negative, it's a plus. So guess what happens here? These two are canceling out because they're exactly the same. And we are just left with this one term. So it's going to be 3 to the power 4, which I believe is 81. and then it's going to be multiply that by 2 pi and multiply that by square root of 3. So that will be 162 pi square roots of 3. Now here is a trick that you could have actually used, and you wouldn't have to integrate at all, like the sine theta and cosine theta, and that just comes from the properties of sine and cosine. So imagine that you are integrating sine over 0 to 2 pi. So like this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. So sine is going to be like this. So first like this and then like that. Now notice how these two pieces are exactly the same, but they have opposite signs. So remember, integral is like a signed area. So this would be like the pink area minus the blue, whatever area. They will just cancel out because they're the same. So integral from 0 to 2 pi of sine theta is just 0, so that we could have just crossed it out. And the same thing will happen with cosine, because cosine, well, if you look at the graph of the cosine, the way it works is that, so pi over 2, pi, 3 pi over 2, 2 pi. So it'll start at a 1, go down to 0, then up to -1, back. So you can also see that like these pieces together are equal to this whole thing. So they will cancel out. So that's why the whole thing, I could have even not integrated it at all and just skipped it. But anyway, this is my answer. So this 162 pi square root of 3. And let's submit that.